Hello, Java programmers. Let's talk about hashing. Not the hash that we eat, but the hashing we do as part of maintaining data inside a program. Big picture, your job as a developer, design and write maintainable code. Your code will be read and enhanced and debugged by you and by other people. Therefore, it's crucial that you write code in a maintainable fashion, that you're modular, that you're easily understood, that you're logically divided into libraries and classes and packages. You'll get better at that as time goes by. The more code you write, the more code you look at, the more people that you interact with, the better you will get at maintainable code. Another job that you have is finding and applying appropriate algorithms. Do you have to control an engine that's about to overheat? Do you have to control a bandsaw that's about to explode because the blade has become dull and the device is vibrating itself apart? Do you have to control a credit card processing system because you're detecting a flood of possibly fraudulent transactions from one part of the world, or a flood of transactions that could be generated by bots? Do you have to control the price of a book on Amazon based on the demand and the throughput for that book and other books in the same category? Do you have to compute how a UPS truck should traverse its route based on the number of stops and the distances between those stops? Do you have to figure out how to sort some data that you're given? Are you sorting it once every day? Are you sorting it 10,000 times a minute? All these things require a knowledge of algorithms, which become very important to you as a developer. Sometimes they will be given to you. Sometimes an analyst will say, here's a flow chart, here's a conceptual design, here's what we need. Sometimes you will come up with your own algorithm. Sometimes you will find a book or another source that describes a well understood, commonly used algorithm, and you'll implement that. Another thing that we do quite often as developers is identify and apply data structures. We can't put everything in a string. We could, but we shouldn't. Just because you can doesn't mean you should. And since we can't put everything into a string, we found out that, hey, it would be nice to put some things into arrays, and then we realized that arrays had shortcomings. We learned ArrayLists, which had some advantages over arrays. They were dynamic, they could be heterogeneous, but they were slower than arrays. And we can step beyond arrays and talk about other ways of accumulating and managing data inside of a program. Here's an excellent book. This is an excellent book because, in my opinion, it was written by a world famous computer scientist from the perspective of software in general, not a particular language. It's language agnostic. And this gentleman also has two very popular computer programming languages to his credit. And he is a very successful guy that he is well worth reading. Just checking the book today, I see that it is $29.94. That's a good deal. Hardcover version, definitely used. They're not in print, I don't think. I purchased mine over 10 years ago. It's great. I don't know if I don't think I've ever seen a paperback version. I guess there is. There you go. Not available, but the bots of Amazon, the Amazon bots, tell us that today it is $29.94. Tomorrow it could be $1, or it could be $300. Who knows? If this video causes a run on this book, the price may skyrocket. Who can say? Highly recommended if you want to improve your skill set, get a good picture of programming in general, not Java in the specific, but why we do what we do and how we do what we do, regardless of what language you're using. And this is pre-OOP. This is pre-object-oriented programming. So none of that clutter is in there either. The concept of a framework is used quite often in software. We have frameworks to let us do categories of tasks. We have a framework for parallel programming, a framework for accessing databases, a framework for communicating with websites. We have a framework for managing data. It's a broad category of software development. Everybody has to manage some data at some point. Your program really is valueless unless it does something with data. I can't imagine a program with no data. And the Java collection framework is a set of classes representing data structures that we can use in our code. The advantage of studying this is that it's universal in Java, and it's also very common or shares a lot of commonality with other programming languages. You learn what a vector is in the Java collection framework, and now you know what a vector is in C++. You learn what a hash tree is in Java. Now you know what a hash tree is in C#. It's probably not called a hash tree in C#, but there is a similar data structure because all of us developers do similar things with our data. We just call the data structures different things across languages. I would suggest that if you're looking for a programming task that's self-contained and open-ended, if you want something to do on a rainy day when Spotify is in reruns and YouTube is down, just grab one of these collection framework classes. Grab a linked list, grab an abstract collection, grab a set, do a little research on what that means, and then implement some code using that data structure. Create a text file, read the data into the text file, manipulate it, write it back out again, generate some random values using a loop, pop them into the data structure. How efficient is it? How long does it take to put 10 million elements into a sorted set? How long does it take to traverse a linked list? What is a linked list? So the more you learn about data structures, the more conversant you will be with your other developers, and the easier it will be for you to apply them when it comes time to write code. You'll identify a problem, or you'll have a problem given to you, and then you can pick a data structure to solve that problem. Another huge benefit for you is the more you know, the less likely you are to duplicate. And one of the worst things that can happen to us is to spend a weekend writing an algorithm or creating a data structure only to learn that it's already built in to our framework. That's a bad deal. It's a good experience in a vacuum, but it's a bad deal at work because you spent time that you could have spent on something more productive. Become conversant, become literate in the Java collection framework, and that is time well invested. The map interface, and we're drilling down now to hashing data structures. The map interface has two parameterized types. Remember, when we see those little delimiters, less than, greater than, the HTML tag delimiters, that is an indication of a parameterized interface. The map interface has two parameters which we refer to as K and V. Therefore, when we're implementing this interface, we have to define two parameters. Now, we call the first one K because it's conceptually thought of as a key. It behaves like a key. And we call the second one V because it behaves like a value. And you can think of this as a row in a table. Every row in a table has a key, and then the remaining columns in that table are the value. The remaining columns in that row are the value. Notice that in this little screen snip I provided, which is from Oracle, it lists all of the known classes that implement this interface, and one of them is HashMap, which we're going to get to in a moment. This is significant in a subtle way because it means if you implement this interface, then there is already code written that knows how to talk to you. If you create a class that implements this interface, then you can use existing Java library code and existing code from other people to do neat things. There's another great reason for learning the interface and learning how to implement that interface. Hashing is a verb. We are going to hash something. It's an action verb. So we're taking some generic data structure. If you want to think of it as a string, that's fine. We're going to take a string. We're going to run it through an algorithm. And out the other end is going to come a number, an integer. That hashing algorithm then takes some data structure, processes it, chews it up, twists it around, and out the other end comes an integer. That integer becomes what you can think of as a surrogate key because it has no value in the real world, but it uniquely identifies a row in the data structure. Now, the hashing algorithm, the process that converts that key, that string, into a number, is unknown to us. We're not mathematicians or computer scientists. We're not going to study the hashing algorithm or the hash function, if you will. Some people call it the hash function, hashing function, hashing algorithm. And that's developed by someone who has a really good feel for math and has spent their career or spent their bulk of their career studying mathematical operations on data. As you might imagine, a lot of people are interested in just what that hashing function is, and sometimes it's a curiosity. We just like to know. Does it have a name? Is it named after someone? Is it someone we've heard of that created that algorithm? And it's on Stack Overflow. It looks like a reasonably popular question. And on the screen snip, it's got 52 upvotes. And if you go to that link, now it's up to 62 from when I snipped it. It's got 6 answers. The accepted answer has 106 upvotes. The answer, and my eye is sensitive to this, and I'm sure your eye is too, there's no code in the answer. So when you see there's no code in the answer, we're drifting towards math and computer science. And that's fine. Those are things we should be curious about, but they are not things about which we are primarily concerned as software developers. If I came to you at Chipotle and said, what hashing algorithm does the hash tree data structure use in Java? You would say to me, I don't know. I'm a software developer and I don't care what that is. It doesn't matter to me. It's like saying, what algorithm does your car use to manage the fuel metering to your engine? How does the car decide how much fuel to squirt into each cylinder? Well, it works. It gets me to school. It starts up in the morning. The mileage seems okay when I put gas in it. I don't really care what the algorithm is, except maybe from a curiosity perspective. We're not going to spend any time on that. What we will spend time on, finally, is a data structure that we can use. And behind the scenes, it's doing hashing. And behind the scenes, it's managing a key and a value. If you know any Python, this is analogous to a dictionary data type in Python. And there are several different hashing data structures in Java. I'll touch on a couple of them here. This again is a snip from the authoritative page of the Oracle Java documentation. And we're looking at a class. We also use the word type. You see a lot of people in the literature use type instead of class. And I usually say data type. But those two things are analogous. So we call it a class. Syntactically, it's a class. We call it a type, or we call it a data type. And it implements the map interface. How about that? So it knows how to take a key, the K parameter, and map it into a value. Notice one very interesting note on this page. Any non-null object can be used as a key or a value. We can hash anything to make our key. We can use a string. We can use another hash table as a key. We can use an array list, an integer, a float, a double. Anything hashes. That algorithm then that is doing the hashing knows how to deal with all of those kinds of data structures. If you dig into this more, they'll give you some hints about performance. They talk a little bit about what they call load factor. How do you balance time and space? Those are all things worth talking about. We're more interested in application right now. But if you find yourself in a situation where your program is too slow or too big, in other words, it uses too much memory, then maybe the hash table could be part of that problem, and you may have to take a peek at it. And that would require some research on your part, some benchmarking, writing some test code, things that you may find yourself doing someday. Now, all of a sudden things get complicated. At least they do to me. Maybe this doesn't bother you as much. There are at least 3 data structures in the framework with the word hash in them. And I can think of a 4th too off the top of my head. Hash map, hash set, hash table. And you should be curious and you should be acutely aware that there is, or there must be, a difference between them. Why are there 3 things that support hashing? And why are they called map, set, and table? Now again, we don't have time to spend in great detail, but I provided a little chart for you here, which is very helpful. One of the things I do want to point out is, which we'll get to in another video, is that a hash table is thread safe, meaning it can be used in parallel processing. And that's a big deal for us because we have multiple CPUs in our machine. We want to make use of them. Therefore, we're going to focus on hash table for that reason. Again, though, you're giving up something to get something. Therefore, if you have a performance issue or a space issue or some other concern, maybe hash table isn't the best choice for you. I'm just planting the seed now that this may be a tangent you want to investigate. Focusing on hash table, it is a parameterized type. a parameterized class. We use K and V because K stands for key and V stands for value. They do not have to be K and V. You can call them P and Q or Sally and Jerry or whatever you want to call them, but typically we use K and V. They're just placeholders. When you declare an instance of a hash table, you'll put legitimate Java types in there. You'll replace the K and the V, and we're going to do that in a second. If you think about it from a 10,000 foot high perspective, if you're looking down on it from an airplane and all you can see is the big picture, it's a little database. It has the ability to store things by a key value. Now the key value for us can be a string or any kind of data type as we saw on the slide, but the key value when it gets hashed is an integer, which essentially is a surrogate key. When we study a data type, we study it from the perspective of speed and performance and memory use, but we also study it from the perspective of what can we do with it. Does it meet your needs functionally? We have to be able to add things to it, remove things from it. Can we search by key? What's the use of having a key if you can't search by it? Can we see how big it is? Can we erase all the elements in it? Can we iterate through it? Can I start from the first element and go through all the elements one at a time to do something with each element? Is there even a concept of a first element? Can I convert it to another type? Once I'm done with it, can I convert it to an array list? Can I convert it to a vector or a set or just an array? And the answer to these questions would be found in the documentation and in your searching skills online, but that's the way that we generally try to relate to a data structure, is what can we do with it? Is it better than an array list? Should I use it instead of an array list? Well, remember from the order of most capable, or least capable rather, to most capable, you have the concept of an array, and it's fixed length. It can't grow and shrink. All the elements have to be the same data type. Then you have an array list. It's not fixed length. It can grow and shrink. It is heterogeneous. The elements could conceivably be different. And it is more flexible, therefore, than an array. But with power comes responsibility and also overhead. You're giving up something to get that flexibility and power. And then the next step up might be some kind of hashing data structure, and I may choose to use that over an array list. Should I use hash tables for everything I do from now on? I just abandon arrays completely? I could do that, no problem. But I probably shouldn't, because A, I'm adding needless complexity to my program, and it's going to run slower. Now, if it's a tiny little program, I don't care if it runs slower. What's a few milliseconds between friends? But I'm also adding the opportunities to make mistakes, and I'm increasing I'm decreasing the readability of the code. So yeah, I could use everything. I could solve all my problems with a hash table and abandon array lists and arrays completely, but my friends would make fun of me, and I'd be sitting all by myself at Chipotle if I did something like that. All right, let's launch into some code. New project, starting from scratch. My hash. That's a good name for a data struct or for a project. My hash. Finish. new class, my hash, package my hash. I'm consolidating everything into one class for the purposes of demonstration. Not a good architecture, except for concept illustration. We would never do things this way in the real world. You know that by now. I have a main. Let's make a hash table. Hash table. It's a parameterized data structure, therefore I need a key and a value. And let's say that my key is a string and my value is another string. And let's just call this my hash, hash table, string, string. Therefore, we have instantiated in the declaration statement. We have an object called my hash. It has been instantiated. Eclipse is not happy. Hash table is not intrinsic to the Java language. Hash table is a class in the framework, therefore you have to drag in a package. And I did this on purpose because I always mess it up. In my mind, it's two words, hash and table. So I capitalize the H and I capitalize the T, but that's not correct. It's actually hash with a lowercase t, so it's all one word, hash table, not hash table. Now Eclipse has probably seen millions of people do this already. Eclipse offers a couple of fixes. I was hoping to see that it was going to provide me an import statement to solve the problem. Bring in hash table library or whatever. It won't do that. It will offer, though, to change it to hash table with a lowercase t. It knows that that's probably what I want. Eclipse is so friendly. I'll take that fix. That's what I should have typed in anyway. And it also dragged in the import at the same time. It did two things for me. It fixed the spelling of my data type, and it dragged in the import statement. So this is part of the collections framework. And I don't know if I spelled collect. I don't know if that is plural or not. I don't know if it's collection framework or collections, but I'm going to go with the S there. I still have another problem though, because the instantiation step is different from the declaration step. Therefore, it only fixed the declaration. It didn't fix the instantiation. But does it offer to fix it? Yeah. Change it to hash table, Bill, because you misspelled it. Okay, fine. There we go. Now we have a variable we can work with. Life is good. Can we add an element? Add an element to the object. Gosh, I don't know how to do that. Let's just start trying to figure it out. My hash dot. Oh my. Looks like my online help is broken. It's not giving me anything. I spelled it correctly. No default proposals. That makes me kind of sad. I'm going to try to just force this to build. And maybe... Nope, nothing. So I'm not getting any online help from Eclipse. When I press the dot, I get nothing. Well, okay. That happens sometimes. Let's go back to our friend, whose name we will not speak, and say Java hash table add value. Looks like it's put. Put method is used to insert a mapping into a table. That means we can insert a specific key and value in its mapping. Okay, put. It's not add. Remember, in ArrayList, it's add. In Hashtable, it's put. You think they'd be the same, don't you? But they're not. Now Hashtable.put. And the first argument is going to be the key. So the key will be the name of the team, and the value will be the city in which that team resides. So the key is the team name, and the value is the city where they play. How about that? When you run that line of code, it hashes dolphins. It takes the string DOLPHINS, it runs it through an algorithm, and it comes out the other end with an integer. That becomes the key that is stored in the data structure. There may be a lot of other things going on too. It's a black box to us, right? It's completely invisible. We don't know what's going on. But in general, that's how a hashing data structure works. All right, I'm going to add a couple more. Through the magic of time lapse, I've added 3 more. Teams and cities. Remember, this is all conceptual. So there is no way that the hash table algorithm or the data structure can prevent me from putting in garbage data. It's just like a database table. So I have to make sure that I put the right values in the right place. Now, can I query how many elements are in the list? I'm getting scared. I haven't done a print statement in about 5 lines of code. I'm starting to itch a little bit. I'd like to print something. System.out.println. Is there a way to print the number of elements in the list? That's always a good thing to know. Again, my help is not functioning today. I don't know why, but I'll go back to my friend, the search engine, and I will say hashtable number of elements. Looks like it's called size. How about that? The size method is used to get the size of the table, which refers to the number of key value pairs. That should be 4. Yay. Happy with that. Can I delete an element? One of those is not like the others. It needs to go. Can I say my hash dot delete? And I can delete by key. That looks unpromising. It's underlined in red. Eclipse isn't even giving me, there it goes. The method delete is undefined. Whatever it is, it's probably not called delete. Again, back to my friend again, Java hash table, delete element. It's called remove. How about that? Is used to remove the mapping of a particular key. I'm deleting by key. And this is from Geeks for Geeks, which I have found to be not worthy of the #1 result. Let's put it that way. A lot of typos in Geeks for Geeks. But that appears to be reliable. So let's try it. Now I don't know if it worked or not because I don't think it's going to tell me anything. It doesn't print, it just does a remove. So this quietly deletes by key. That key value pair is gone now. I guess I'd like to print the whole thing. Print the whole thing. Print the contents of the hash table. Can I do a toString on a hash table? Remember, toString is always there. Has it been well implemented in the hash table data structure? Let's try it. System.out.println myhash.toString. Spelled my hash wrong. What do you think is going to happen there? Let's find out. Well, that's pretty neat. Inside curly braces are all the elements of the hash table in key value pairs separated by commas. Packers equal Green Bay, Dolphins equal Miami, Bengals equal Cincinnati. Key equals value. Notice the order of those things is not the order I put them in. Not even close. Things in a hash table are not stored in any kind of order that you can count on. So it is not an ordered data structure. If that's a problem for you, you should be using some other data structure because you can't count on them being first to last the way they were inserted or the way they were put into the data structure. And that's okay for debugging. It's kind of nice, but it's not useful for other types of processing. So what I really want to do is be able to iterate over the data structure. That's what I want to do. Eventually it's going to come down to that. Everything, well, at least in my experience, every data structure at some point, sooner or later, you've got to iterate over it. And even if I don't care what order it's in this case I can't care what order it's in, I don't have any control over order, I still want to iterate, and that's going to be an enhanced for loop. Now, how do you do it? Well, I know that the key is a string, okay? So I can declare that enhanced variable as a string, and I can call that k for key, or I can call it key, either one, or I could call it team, right? Because I know they're teams if I want to be particular to this data structure. But I can't just iterate over the name of the data structure. Java isn't willing to do that. Python, yes. Java, no. So I need some other syntax to get the iterator from that data structure. Now I know it's there, but I can't remember what it is. Let's just act like I can. Is it called iterator? No, it doesn't like that. Is it called elements? Doesn't like that. So I'm not getting there. But the error message is a little bit encouraging. Can only iterate over an array or an instance of java.lang.iterable. And I can't do that because I haven't provided anything that's iterable. Now I know a hash set is iterable because it implements the iterable interface, but I don't know what the method that I need to call. So I'll go back to my friend again. Java hash table, iterate through keys. Looks like what I want. Whole bunch of choices. W3 schools, they're always good. Oh, that's their blog though. Let's try SO. No reason but to get a different perspective. I have a hash table in Java and I want to iterate over all the values. That's exactly what I want to do. Okay. They're using a different syntax, while, and then they're using has next. Okay. So that'll work. But that's not what we're doing. There's another one, has more elements. So let's just try keys, because I see keys right there. Let's try that. Doesn't like that. The keys collection is not iterable. Can only iterate. Okay, so I'm still striking out, but that's okay because we're here to learn and experiment. That's no problem. Let's try to change my search phrase because I'm getting things that don't really look familiar. Let's go iterate enhanced for loop because I know I want to use an enhanced for loop. And Geeks for Geeks comes up again. Okay, fine. I'll try it. I'm scrolling down looking for code. I'm not even reading the text. I just want to see some code. Well, they're using more elements again. They're using a while loop. Method 2. There's a key set method. Okay. So they're using a method called key set, and here they are popping up all kinds of stuff. You can see another reason why they're annoying. So apparently key set is iterable because they went to all this trouble to create this variable called set of keys and initialize it when they could have just plunked all of that code into the enhanced for loop. So memorize key set, open close paren, and let's put that in our code. There we go. That's iterable. That's going to give us something we can iterate over. And then inside here we'll just do a print. System.out.println team. And there are the 3 remaining values. That's what I wanted to do then. And as you saw, I found other ways to do it as well. Is one way better than the other? Doubtful. That would require some benchmarking and study. But I got it to work. And I got it to work using an enhanced for loop. That makes me happy. All I'm doing, however, is printing out the key, the team. I'd also like to print out the city. That means I should probably do a lookup. And use my hash table lookup capabilities with that key. So my hash dot. Now again, I don't have any help, and I didn't plan it this way, but oh well. How do I use the key, which is team in this case, to look up the corresponding value? Well, the opposite of put is get. How about get? And then I'm going to put the key in there. Well, no news is good news, and since I don't have any Eclipse support today, I'm going to have to reboot when this video is over. Now let's see what I get. That looks better. So I used a put to add something to the hashed set, and I used hash table, sorry, and I used a get to do a key lookup against the data in the hash table. Let's do one more thing in this video, and that's let's do what Mythbusters does. Let's try to break it just for fun. So let's do a while true, infinite loop. Gonna run forever until something bad happens, and we know something bad will happen. The machine will turn off, the power will fail, the CPU will melt, or maybe it'll just run out of memory. Could be a destructive bad thing or just a harmless bad thing. Let's just put something into my hash dot put, and let's put in a random number. How about that? So I'm going to create a random number object. Of course, it doesn't know what random is. And please tell me you'll add the import statement, because I don't know what it is off the top of my head. Why did the help just stop working? Oh my word. Well, I know I need an import, so I'm going to go look that up. I'll be right back. I added java.util.random out of my head, believe it or not. I don't do that at all. Usually Eclipse does it, and I couldn't be sure I knew the answer. So that worked. Now I have a random number generator. The put method of the hash table class requires a key, and that's why I have that error there, because I'm not providing the key as an argument, but Eclipse is not. So that needs to be a string. Now if I say r.next int, is that right? r.nextInt is correct. That's just the next random integer in the random number sequence. But put's not happy because put wants a string, right? Yeah. The key to my hash table, I promised the world it would be a string. But I'm not. I'm trying to pass an integer. And that commitment was made up here. I committed to the world that I would be sending a string as the key. And that's the value of parameterizing a data structure, is that you get this error, and Eclipse can tell you you're making a mistake before you make it. That means I need to convert this to a string, and that means integer converted to string, and I can probably do string like that. No, I can't. Okay, so I can't do that, and I know why, but I won't go into it. Now I need to convert an integer to a string, so I'm going to do string dot value of open paren close paren. And is it happy about that? Oh, my mistake. I need two values there. I need a key and a value. I'm so sorry. So that's going to be comma, and what's the second string going to be? Oh, I don't know. Test. It doesn't matter. As long as the keys are unique, it doesn't matter what the values are. So now I have this really lame while true loop, this infinite loop that will run forever and cram unique keys into my hash table until something goes wrong, which is what I wanted to happen. Although I am a little bit nervous because this may negatively impact the video recording that's going on in the background. So it shouldn't, but it might. If I don't talk to you again, you're all my friends and I admire all of you, but let's try it and see what happens. Here we go. Run. Now when it runs, it won't look like much because it's just going to sit there. It's stuck on line 32. The terminate light is lit. That means the program is running, and I can terminate it by clicking that button. Now performance is dragged to a halt. You can see that if my recorder is working at all, I'm having a heck of a time even getting something to run. I just want to show you Task Manager if possible. I'm having a hard time. If you look at the CPU usage, you can see it's spiked. Something very computationally intensive. There's no I/O that needs to be done, and it's just locked. And you can see that Eclipse is about 61%. So Eclipse is consuming a lot of power. It's consuming a lot of CPU time, and it's also consuming memory. You can see the memory usage spiked. The reason it doesn't spike to the very top, Windows is smart enough and Java is smart enough not to try to use all the memory. So it gives me a sandbox to play in, and that's all I have access to. Luckily, I have about 13 gig, which is why the screen recorder still works. Anyway, if you're still with me, I am going to kill this because it's making me nervous. I'm having a hard time killing it. There it goes. There, it should be done now. Okay, so that's better appreciated in a live demonstration where I can let the computer just hang itself. But since I'm trying to record, I'm running a risk of losing you and maybe losing the entire recording. So with that, we will end this video. Hopefully it was useful and interesting. Go learn some data structures in the Java Collections framework and put them to use. Thank you and goodbye.